think I'm live, but this is always the point in time where I need to double check the actual browser window to see if that's the case. So I will type going live right now, refresh. Yep, and I seem to be live. It's going live is such a weird thing. Like I can have this browser window open and it says I'm not live yet. Then I hit refresh on the browser itself, and then it says yes, you're live. Kind of a weird situation. But as people are joining now and tuning in, do let us know where you're tuning in from. Today we are going to be talking about a library that I made, and the library is called FlowShow. And if you go to GitHub, you can actually, see a GitHub repository, see a little bit of a demo. But what you see on GitHub is actually a little bit old, because I added some pretty cool features last week that are mainly just local here, and they're pushed and stuff, but the README is not updated yet. And the goal of the day is to talk about how you can get, a normal Python program with functions and stuff to eventually look like a dashboard like you see over here. And the way we're going to get there is we're going to come up with some very clever decorators, and then we're going to apply a bit of a Jinja trick that allow us to turn a Python program basically into a dashboard. It allows you to kind of see how the program ran. Now, let's talk about some building blocks in order to get here, because there's a couple of party tricks, I guess I'll say, that are just kind of nice. So, start. I'm going to make a function called start, and let's just zoom in here. So, start here. That's the name of a function, and let's actually use some nice logging methods. So, I have this info logging method. We're going to see in a bit why that's useful. Function is starting. Let's do a time.sleep here. So let's sleep for a second, and then info, like I say, function has stopped. Then what I can do is I can call this function start here. It takes a second, it runs, and that's about it. Nothing really special is happening here just yet. But what I can do is I can turn this into a task. So the way this is going to work, I just have this one decorator. Yeah, just a normal decorator should be fine. And that's going to make a little bit of a change to this function over here. So without this decorator, the start here function is an actual function. But the moment that I add this decorator, this function becomes a task definition. It will still behave like a function, but you can imagine there used to be a function, and now there's an object that just wraps around it. I can still call the function, I can still call the object as I would normally, but we're tracking some state is the main thing that's changed here. And if I were to run this function, right, it runs like normal, like nothing really weird is happening just yet. But after that function ran, I can have a look at that. I guess it's a task, right? That task definition, if I look at the stuff that's in it, there's a function, which is this original function that I started with. It has a name, and there's all sorts of settings, but there seem to be some task runs attached now. And that's kind of interesting. So I think there's a property called runs, if I'm not mistaken. There you go. And that's a task run. So, and what I think I can do is I can maybe run this function twice. Let's do that. And it takes a while, of course, right? But if I run the function twice, then there are two task runs attached to that one task. Okay, so, we're carrying some state. That's the thing that's happening here. Like that decorator is making this into a task definition object, and we can carry some state. That's kind of funky and nice. But what I can also do is I can call render on this guy. Or did I not have that? Or last run, yeah, and isn't there a render method attached to it? There we go. So I can grab one of those runs and I can render it. And this is a proper HTML file with lots of JavaScript. Oh, hello from St. Louis. Hi there. And in order to properly render that, because there are some JavaScript protections in Marimo, that's a good thing, I do have to wrap that in an iframe to actually go ahead and see it. But if I were to now kind of just zoom out a bit, that one function that just ran has a little dashboard. There's a function called start here, and I can click this row, and I can see like the start time, the end time, and notice that info stuff that I was using, that appears in pretty logs down below over here. And I also get some other stuff like, hey, on what file is this function stored, and what line, and can we get something of a signature? There's also dark mode, by the way. But that one HTML blob, you can store that on disk and open it up in a browser, or you can also open it up from Marimo in this particular case. And, you know, that's already kind of cute. Like, one thing I can do here as well is add like a warning. Oh no, exclamation points. I think I can do that as well. That's also a helper. Wasn't that a helper? A warning, sorry. So that has to be warning. Right, and if I now inspect the logs, you can see there's a pretty color here as well. So that's also just kind of cool, right? So we have pretty colors and all of that. But there's also some, like, the thing that I think is really cool about what's happening here is like, a program, of course, isn't just a single function call. We typically have multiple functions happening on the inside. So let's add another task. Let's call this one inner thing. We can come up with better names later. And again, let's do an info inner thing. And from here, like, another thing that we can also add is we have the info. Let's do another time.sleep, but have this one be like pretty fast. Something like this. And then what we can do is inside of start here, I can do something like for I in range 3. I'm going to just call that function a few times. So I'm just going to call inner thing inside of that. Let's see what happens now. So all this stuff has to run. But now you can see that start here starts to run. And oh, on the inside of that, and I can close this and I can open it up. Inner thing is actually running for a little bit. And oh, this is actually kind of nice because I can look at, you know, this is the main function. Inside of that, I've got these nested functions. And oh, having a little bit of a time view here is definitely kind of cool. But oh, what's also just kind of neat is that I can always inspect the logs of the thing that happened inside of it. And this is the whole point of FlowShow. The whole point of FlowShow is that we give you, or that the library just gives you tools that allow you to inspect the flow of a program. And the reason why I think it's pretty exciting is it has a couple of these nice features that are just interesting for Marimo users too. Because we have this we have a state that's basically JSON that we can keep on accumulating, and there's useful information that we can add. And you can always then turn that into some sort of an HTML thing that's fully interactive, and you can just add that to the front end. Because this is a notebook, right? So we can always have whatever HTML with some JavaScript at the ready, and we can always put that inside of a iframe. That's something we can always go ahead and do. And because Marimo is, of course, a notebook, you know, we can show that. So it feels like this is kind of a nice thing. But we can also start thinking about, like, what are some extra bells and whistles to add here? And I'm going to talk a little bit about how this is implemented, because it is kind of a funky thing, right? Like, how on earth are you able to track all of this? Hint, it's a global. But hopefully people can also look at this and say, this is actually just kind of useful. It's kind of nice to, also when you're debugging, when there's a big program, where you're kind of wondering in what order are things running and what part is actually taking a while. Like, all of that stuff is just kind of nice to be able to inspect in hindsight. So that's what this task span visualization is sort of all about. You can add these decorators, and that allows you to basically track stuff. But there's some extra bells and whistles too. So we can attach a callback to a task, like when this function runs, run something else automatically. There's also a retry mechanic that we can attach here. So like if a function fails, maybe we want to retry it a few times. So just to demo that, if random.random, if that is, let's say, I don't know, less than 0.5 or 4, whatever, raise value error. All right. Oh no, something went wrong. And let's zoom in as well so people can actually see it. But I'm not going to run this. And we see, oh no, something went wrong over here. And that causes this cell to fail. And because that cell fails, all its children also automatically fail. But there's still actually state attached to that object. So if I were to rerun this manually, then I'm able to see that, oh, start here failed because the second iteration of inner thing failed. So, oh, for debugging stuff, it's also just kind of nice to see, like, if you're clever about the logging and the things that you add here, right? Like, oh, you can kind of easily see where something is failing. So that's also just kind of a nice thing to have here. This will be an excellent point in time for people to ask questions if they have them, by the way. So this is kind of the goal that I had for FlowShow. Like, you know, I just want to. I was basically just thinking, like, hey, what can we do here? Like, this is basically like recreative programming that I was doing here. But then I showed it to a colleague, and we kind of started thinking a little bit more seriously about this. Like, hey, it's cool that you have decorators like this, right? But if you're going to do this for realsies in a notebook, is this what you want? Because it's cool to be able to add a decorator to a function. A function is a nice mental building block of things that have to happen, right? Oh, and people are saying like, hey, for multi-agent orchestration stuff, that could be super useful. Yes, I'm going to show you a demo of my agent that is doing this. It is super useful for debugging and inspiration, for sure. But one thing that is a good observation at this point, like if I run a notebook, then do I really want everything to be inside of a function? Because you get annoying things like this, right? Like maybe there's something I return over here, and let's say value is happening over here, and then something goes wrong with the value variable over here, and then I raise a value error here. Oh no. Oh no, 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 no. Okay, and then I have to rerun this again. But like the annoying thing now is, oh, a bug happened apparently and start here. Oh, and I would like to maybe inspect a variable, and oh, I can't because this variable was inside of a function, I can no longer reach it. So that's this might not be the best way to do entry points if you're working from a notebook. So there's something else that you could do, and that is that you can use what I call a span. So instead of doing this, like, hey, let's decorate all this in a task, what you can also do is you can say with span, I want to, yeah, keeping track. That's the name of this guy. As f, yeah, as, I guess, entry points is the name to maybe call this, right? Then now, because this is a context manager, if I were to run this now, then start here no longer exists, so that's fair. But now I can use that name, that entry point variable. Yeah, no longer task run is no longer relevant, but I can also use that context manager now, basically. That's kind of the interesting point. So by using a context manager, like why is this useful in a notebook? Well, having a context manager basically gives you the same thing as that task object. It basically is still a task definition. But the main thing that's interesting is that I still have access to whatever variables that I've declared on the inside here. So when I'm debugging something with, I don't know, like as Ty suggests with an LLM, and the LLM returns something and it caused an error, whenever that happens inside of a function, I can no longer use the notebook to debug. But if I use a context manager, oh, then I can still use the variables that are declared on this scope. And one thing I can also do is like nest these spans. So I can do another span here, like on the inside as another. Actually, I don't have to give this a name, because I think if I were to just do this, right? Yeah, sure, this is nested, but you can see that these spans, they actually, it's kind of like having a task inside of a task. So you can definitely, you know, do the logical thing. Like you can basically have a hierarchy in your code, and this thing will just show you the flow of it. That's the whole point. And what I have found super duper useful from the perspective of doing this in a notebook is that when the notebook starts getting complex, this starts making a little bit of sense, right? Like I can log things very specifically. I have bespoke tools at my disposal. But the really cool thing here is that this is, of course, like a nice little visualization as well that we can attach. And like some thoughts I've had with this is basically a static HTML file. And that's kind of useful too, because maybe when you run a Marimo notebook as part of a cron job, like that's something I'm thinking about. Like maybe we want to have something like this as an artifact. So instead of looking at a big log file, we can produce something like this. And then, oh, it's much easier to find out when something broke maybe. Like that's kind of an interesting thing. Another thing I can also do at some point is maybe wrap this inside of an any widget such that this becomes like properly something interactive and not something that's static, because right now it is really a static HTML file. But I don't know, like this was pretty useful. Like I was sort of fooling and playing around. And then I had some colleagues that I showed this to, and they actually told me about this feature of Marimo that I didn't know about, which I do want to show now just very briefly. And that is that we have this tracing functionality over here. So what I'm going to go ahead and do now is I'm just going to remove this code over here, as well as this code over here, as well as this code over here, because this notebook has a general thing that it can run. And let's just restart the notebook, actually. Yeah, so there's no traces right now. And if I'm going to zoom out, I'm just going to run this notebook. I have to zoom out a lot because I'm using multiple columns. I'm just going to restart the notebook. Yes, zoom back in again. But you can actually see that Marimo itself has a bit of tracing functionality in it. It's just that this tracing is happening on the cell level. So you can see when different cells ran, and you can also see which cells actually took a bit longer, which cells took a bit shorter. You can inspect it. You can go to the actual cell. So like one thing to just really observe here is that the stuff that I'm doing, it goes a bit more in depth, right? But there is already tracing functionality inside of Marimo if that's something you're interested in. And I do think having stuff like this on the cell level also makes a lot of sense. So that's just a thing to keep in the back of your mind. The interesting thing about working at Marimo is that we tend to have a very high rate of pushing new changes. That is actually relatively normal for me not to know about all the features at any given point in time, just because 1 week passes and we actually typically ship a whole bunch of features as well. So this is a feature that was around for a very, very long time. But yeah, you can also have an inline chart if that's the thing that you like. But this is also like a useful thing if you're running long-running notebooks, and if the cell structure itself has a lot of information that you want to keep track of. So that's also like a thing to keep in the back of your mind. But an extra thing I do want to mention about FlowShow. Oh, and yeah, let's actually zoom out now and let's actually make this a little bit thinner. I really like to work in my notebooks with multi-columns these days. But what I've got here is like an interesting demo. So one thing I made here, like as the first demo, like just to show off kind of all the bells and whistles. So I have a task decorator here. I'm adding that to this thing called my function, and you know, this there's all sorts of settings that I pass here. One thing that I want to show and highlight is that there is also this add artifacts function that you can call. And what this allows you to do is just add a couple of artifacts to basically the span run. Like whenever this function runs, we're going to just log some extra artifacts here. And you can do that with you know, normal args, quargs, and dictionaries and stuff. But you can also use Pydantic objects because those are popular these days. And no, I've got a main job and it's doing all sorts of nested things in here. It's also got a couple of spans. And if I have a look over here at what that view might look like, another thing to also see, let's do dark mode. Actually, it looks a bit weird. Let's just do this. But one thing that's also interesting is you can actually distinguish a span from a function that ran because the letter over here changes. So I can expand and stuff. But if I go to my function over here, there will be this thing over here. Like I've added artifacts, foo, bar, and buzz. And you can also see that being rendered on the side over here. So you can actually get quite expressive with things that you might want to render. And which one did I have? There's this function called main job. That would be the main thing on top over here. And that one also has this one artifact called many-bar, and that is a Pydantic object. And that Pydantic object is properly translated into JSON, and that's something that I'm showing here. So if you have very important like inputs that you want to also keep track of and that help you debug, that's also something you just attach, so to say. So people are asking some questions. Yeah, we are pretty fast shippers. That's definitely true. And yeah, what do those colored boxes indicate? I'm assuming you mean this. This indicates if it's a function or a task that you're logging here, or if it's a span that you're logging. And I felt it could be like a nice way to like at least make something of a distinguishing case here. Some people are comparing this to prefect, and you know, I can see the similarity. I will say that prefect does a bit more though. Like prefect will actually send all that data to some sort of central server and will keep track of stuff there. This is something that is, at least at the moment, really designed to just run in your normal Python program and do some extra logging on the side. And I have found this to be pretty useful inside of notebooks, but I'm not sending anything to some sort of a centralized server or anything like that. The whole point of FlowShow is that you're just in control and this stuff is running locally. And like the kind of thought I always have in the back of my mind, like whenever I'm running batch jobs, the feature that I always want to have in the larger system is that, oh, something goes wrong, and I need to have one place where I know that if I go there, I can start to debug and most of the information will just be there. Like the thing that's always very annoying is if a batch job fails and suddenly you need to access 6 systems in order to figure out what is actually happening, because this part of the logging happens there, and this part of the logging happens in MLflow, which is a different service, and you have to sort of figure out stuff there. And something about, for me at least, something about declaring very specifically important things that have to be logged, and that I'm also kind of free to add whatever I like here, that is definitely super useful and nice. And one thing I'm also thinking about is like, would it be nice if I also maybe had a table thing I can add stuff to quite easily here. And what might be, can I also add charts and stuff like that? That's the stuff that I'm thinking about. The downside of doing stuff like that is that the blob and like the JSON thing I'm collecting and the HTML that I'm collecting, that thing's going to get bigger and bigger and heavier, especially once you start doing images and stuff. So I don't know about the future, but I think this is still, this is kind of nice. Some people say it also reminds them of temporal. I've never used temporal before, but I like Logfire also does something that's relatively similar. I don't know if you like the Pydantic people make that. They have a proper, they have a pretty decent, I would say, like span collection tool. That's also meant for more production services. What I'm doing here is really mainly focused around batch jobs. Like I would not hang this inside of a Flask server anytime soon. Like that would definitely break because I'm doing stuff with a global, right? But there's one extra feature that I want to talk about that I added kind of on a whim, but that turned out to be like super useful, especially in the realm of LLMs. And I did not expect that, but it actually makes a lot of sense. So what am I talking about? I'm going to zoom in a bit. And when I go down here, you're going to notice that, hey, the functions I've shown you so far, those are all normal Python functions. But in real life, right, you probably also want to be able to do async stuff. That just makes a lot of sense, right? So can we also do things with, asynchronous functions? And the answer is yes, we totally can. This task decorator can understand that if an asynchronous function goes in, that we should handle it just a little bit differently. So I've got this async sleep function. It also does the info thing, and it returns something, and I can definitely tell it to go ahead and sleep for a bit. And I've one async function over here that sleeps for 2 seconds, another one that sleeps for 1 second, another one for 3. These are all tasks that I've defined up front that I'm calling async.io gather. It's going to collect all the tasks, right? But this is what it looks like from the FlowShow dashboard. This is the main function, and then inside of that, I've got some concurrent functions that run independently of each other. So you can very clearly see there's an async sleep here that takes 1 second, another one that takes 2 seconds, another one that takes 3, and these 3 all run concurrently, after which I'm running this main function that runs these 3 one more time, and again, you can see that all stuff runs nice and concurrently. And I will say, something that I really started liking is, for some programs, you kind of look at this and you kind of go like, oh, that looks kind of like a waterfall, right? Like that kind of works. But then at some point, you also start wondering like, gee, that really looks like a waterfall. Should it maybe look a little bit more like this, where there's just parts that actually run in parallel a little bit? And the weirdest thing happened where I built FlowShow to help me inspect a like LLM job that I've got, and I just got so frustrated by the shape of the chart that I saw that I actually started adding async support, and then I started rewriting my code such that it could actually do the async thing. Because at some point you look at this and you kind of go, "This is ridiculous." Like you need to be able to do stuff in like somewhat concurrently at least. I've not checked this stuff for parallel workloads yet. I think I want to wait until Python 3.14 is like mainstream, but I do think in an I can quickly eyeball, okay, the way that this program runs, or the way that this program runs, there's a preference because I can see stuff that runs concurrently or somewhat in parallel. And especially when you're communicating with LLM providers and over the internet and all that stuff, that has proven to be stupidly useful, actually, because it's just a reminder in your face that your batch job can actually be a whole lot quicker. And I think I'm going to show you an example in like right now. It's this one. So this is a big LLM job that I've got, and I've got like a main cell, and it's doing a whole bunch of things. But you can see that there's still a bit of a waterfall because I don't want to do this fully in parallel. But you can also see that there's like a little bit of concurrency happening under the hood. So 3 things can kind of run in parallel, and then at some point I can run 3 more things and 3 more things. So there's a little bit of concurrency that's happening, and especially when you consider that any one of these requests can take 10 seconds. Oh my god, being able to run that not sequentially is huge. So I'm gonna maybe just explain what this job does. It's a bit of a silly project, but I figured that like it helps to know a little bit of context before showing you a chart. I have this silly little website called the Daily Bin, and it started as a bit of an experiment. And it really is an experiment. And to be honest, I thought it was going to be way cooler than it turned out to be. But what you're looking at here is a website that is kind of like my own newspaper. But the way that this newspaper over here works is I'm saying, well, there's a lot of interesting conversations on Hacker News, and what might be fun is if I every day just check the latest state of Hacker News, and I just try to do LLM stuff to figure out what are the most interesting conversations, and then turn those conversations into news stories. And then for extra credit, I also figured, hey, it might be fun to also have like images be generated for like the newspaper title that I see. So this is today, this is yesterday, and the images that it generates are actually pretty interesting and good. There's also, let's turn in, it's dark and light mode, and there's an RSS feed, and it does look a little bit like the New York Times, which I thought was also just kind of cute. And there's fancy animation and all that good stuff. But you can imagine there's actually a fair amount of LLM stuff that needs to happen in order to get this all to work. It is a GitHub scraper job, so this is basically all running in GitHub CI. So every day I'm just writing files into my GitHub profile, like in my GitHub repo, and then every day there's like a JSON blob that's updated. Every day there's an HTML file that gets updated, and that isn't automatically pushed to Netlify, and the whole thing is pretty stateless in that sense. But let me maybe just draw this situation as well, because that tends to help. Yeah. So every day there's like a Hacker News endpoint, and Hacker News, there's an Algolia site, I think, that has a JSON API. So every day there's basically a job that says download the latest Hacker News data. That's a big JSON blob, like a really big one. And then I just look at the titles, and there's an LLM that basically says, look, out of the 50-odd stories that we've got over here, let's just pick the top 10. And, there's a bit of a prompt that says something like, hey, here's stuff to prefer, here's stuff that's not as interesting, something of a prompt. And it sort of guesses what the 10 most important stories are. And I also do something like only do popular items, like don't do items that only have 5 upvotes or something like that. Once I have got that, the next thing that I can go ahead and do is I can have a look at the conversation. So there's like the conversation 1, and then there's conversation 2, and this is all like a nested JSON thing. And I can flatten that and then send that off to an LLM to make a summary. And that is basically my article. So there's an LLM over here as well. And there's an LLM over here as well. It's going to generate the article. That's the text as well as the title. So that's all the stuff I have for written content. But then after that, there's another step, because for each article, I use an LLM to turn the article title into a prompt. And that gets sent off to an image generation tool that is hosted on Replicate that I pay for. And that is going to generate me an image to go along with that article. But the thing that's kind of important at this point is that before this thing was just fully sequential. This takes about 10 seconds, and I think this also takes about 10 seconds. So you can kind of imagine if you were running all of this sequentially, even though they're all just like, normal web requests, it's just going to take so much time. So the way everything is now set up is I am going to first wait until all of the LLMs in this step are done. And after that, I'm going to be running these. And then once that's done, that's also just done. But there's a max concurrency setting. I think I've set it to 3. So, this part is just going to sort of nicely batch up. And I can expect similar behavior here. And really, the thing that led me to actually do this isn't so much the final number that I saw on my GitHub Actions thing. It was really just that one chart that I saw. Like, I really like seeing FlowShow charts that look like this, as opposed to FlowShow charts that look like this. Like sometimes you have to write code this way, but especially if you're communicating with LLMs and you want to see that stuff is pretty fast, this is more the stuff that you want to see. And if I have it right, this is also the stuff that I kind of see now. So first, I'm generating all the posts. Let's actually get my pen out. Yeah, and that's the stuff that I'm doing over here. So this is me generating all the posts that I need. And once all the posts are in, then I'm going to be generating images. And those images, they're also using the same sort of concurrency mechanism. So that's also something that can semi-run in parallel. And you can also see, like, when I generate a post, I can also see, like, hey, what's the summary that's been generated? What's the title that's been generated? There's a bit of an introduction text. That's also like the introduction text. If you go to TL, the daily bin, like the text that you see at the bottom here, that's kind of a summary of a summary. but like hopefully people can sort of look at this. This was like just an LLM experiment that I wanted to do because I was just kind of curious if it would work. But you can imagine that there's a relatively complex notebook that's sort of attached to this, and there's all sorts of like this is like a prompt, for example, like, hey, there's messages that are coming in. Write a short NYT article about the themes that are being expressed in this text. The main summary should be about 5 paragraphs long. Make sure you spend time discussing the major themes and viewpoints. Pretty long prompt. But this is stuff that I log now, basically. And honestly, I thought the main thing that was going to be super useful and cool was the stuff that I was able to log here, right? Like maybe adding logging the prompt and all that stuff that's going to be super useful in hindsight, and it is. But gee, the thing that I also really like is just this. Like whenever there's something going wrong or when there's a retry that's triggered, I see that stuff, and if in hindsight something breaks, the fact that I have this view together with the fact that I'm able to use a span such that I actually have all of these variables available to me, like they're not hidden in a function or something like that. Something about that was just kind of a nice flow, and that's also just the thing I want to present here. Like, you can come up with tools inside of a notebook that make for nicer experiences when it comes to batch jobs because we have a browser at our disposal. Period. Like that's just the main observation I had when building this FlowShow thing. And, it's early days. This is a personal project. It's not necessarily something that Marimo backs, right? Like I was able to work on this a little bit because it was for this live stream, but the main thing that I think is interesting to explore here is, can we come up with tools such that notebooks themselves are just cooler to run bash jobs in? And yeah, I do think, especially now that you can do a little bit of vibe coding, right? Like I can imagine stuff like this becoming a bit more of the norm, where the notebook experience becomes the batch experience. The batch experience can also become the notebook experience. And something about that just feels super exciting to me. Now, there are definitely still some performance things I want to think about because, this can become kind of a big HTML blob if you're not careful. So maybe doing this with an any widget, could be kind of better. And then the data structure can also be sent to some sort of backend that can render it. There's also the stuff that we could explore here. But this is FlowShow, and this is also what notebooks can be like if you want to maybe optimize them for batch jobs. So it's again also still nice and self-contained. This will render whenever I render the notebook. The one issue that I do want to maybe mention, this static HTML file that I've got over here, that is amazing because I have this function called mo.iframe that can actually accept that big blob of text. If you were to take this entire notebook and turn that into a static HTML file, because Marimo does have this export functionality, so you can download this as a static HTML. If you do this, then this doesn't get rendered as nicely, and there's reasons for it. But like, I still don't know for sure if I maybe want to save these things to disk, or if I just want to have this as a debugging utility for when I enter the notebook. So those are still ideas that I've got in the back of my mind. But this is FlowShow. This is something that you can already play with right now. If you pip install FlowShow, you've got these decorators, and yeah, for like doing some rudimentary logging on some stuff related to LLMs, I've actually found it to be quite useful, in particular because it helps remind me of I want to see charts like this. I want to see this concurrency. I can just see that in one fell swoop. That's something that's definitely kind of cool. So, any questions on this? Because the next thing I could do is talk a little bit about the implementation, which is a bit of a hairy deep dive. Like it's a bit of a hack that I'm doing, but I'm still kind of proud of what I've done there. But if there are any questions about this, I think the demo is good. Feel free to maybe just ping right now if there are any questions, because otherwise I'm going to move on to some other things. Because this basically wraps up the main demo, I would say. Just to check if there's any questions. No, seems fine. That means that we can go ahead and have a look at the implementation. So this is the FlowShow in VS Code. Actually, let's just add a new terminal window here because git status. I pushed everything right. Yeah, so I think you should be able to pip install this right now. Do make sure you get the most recent version, by the way. But let's have a look at how this is implemented. So there's this visualization part of the code base. I need to refactor that. But this is the code that I'm currently using, and yeah, there is like the thing that I do. There's a lot of code here basically, but let's just start here. So there is a task run, right? So I have a decorator that goes around a function, and then that turns the decorator into a task run. And I think the decorator, let's actually go look for it. Task. There we are. So this is the decorator. So a function goes in, right? So, but this is the decorator I can wrap around a function, and as an internal decorator, et cetera, et cetera, et cetera. But the main thing that it will do is it will take the function that I give it, and eventually it will return this task definition. So the task definition still has access to the function. There's extra behavior around it, but the function that I'm going to put in here, that is going to be put inside of a task definition. And note for good measure, I'm doing some extra things to the function that you give me, right? I'm going to apply some retry mechanics. There's also some logging things that I'm doing whenever there's a retry happening. So I'm doing a little bit of extra stuff, but basically the main thing that this task decorator does is it turns the function into a task definition. That's basically what's happening here. Okay, so what is a task definition? That's great. Where is that class? This is the task definition class. Again, it has like a callback, it has a name, it has a callable, it has a bunch of things. You can call this function, so you can do stuff like, hey, if it's asynchronous, we're going to do that slightly differently, but the dunder call is basically making it behave just like the normal function is. But let's have a look at that sync call then. So when I call the function, I start a new task run object. So the task definition, that is to make a definition of a task. But whenever that task runs, there's a new task run object that I'm making. Oh, so Shamir is asking, hey, isn't this using any widget? No. So right now, this is just using normal Python code, and it can and it does something at the end where I've got a big JSON blob that just has all these task runs, and that is something that I can use inside of a Jinja template. That's this sort of the most straightforward, direct way to just reduce the amount of complexity needed. Also because LLMs will help you write a Jinja template a lot better than an any widget. But also the thing to remember here, like why would you use any widget versus like just some sort of Python object that is able to render just kind of nicely? And like a thing to always remember is that in any widget, what's kind of nice there is you basically have Python that can interact with JavaScript in the front end, basically front end Python. And, Python can change JavaScript, JavaScript can change to Python. But the stuff that I'm doing here, like, yes, there is JavaScript such that if I hover over something, something else updates. But any JavaScript that I've got over here, it doesn't have to interact with the Python object, actually. It's not like there's shared state that needs to be updated. It's really just a view. And in my mind, I do think if you're dealing with something that is really just a view, then at some point it makes a little bit less sense to implement that as an any widget. And it starts making a little bit more sense to maybe consider rendering that as an iframe inside of the notebook, just because it reduces the surface area of complexity just a little bit. Of course, you can write it as an any widget, and there could be reasons to maybe consider that. Like one thing I have noticed is that maybe putting everything in an HTML file does make it big, and it can maybe make the browser a bit slower. Like that is maybe a concern. But I always try to make the quick implementation first, which is why I don't mind actually if we just have a static representation where sure there's JavaScript, but that representation is still just simple, at least initially, at least. Because also when people want to make a contribution, updating a Jinja template is a lot easier than maybe updating an any widget. The Jinja people community in the end is still a bit bigger than the any widget people community, so to say. So, having said that, I have a synchronous call. I have a task run. It's a run. That's just a run. But So this is where the magic is sort of happening. So this is a task run context, and I'm going to be capturing lots of logs, but but eventually I'm going to call self.func. And this is the function that I'm actually calling. but you'll notice that there's a lot of stuff around it. So before, the stuff that was around it was really there for retry mechanics. So this function over here isn't the original function that I added. This is the function that the task definition added, or the task decorator, I should say, added a whole bunch of retry mechanics to. But there's extra stuff that I'm doing over here, like capturing the print statements and making sure that there's also like the time taken, like how long did this function run, that I'm storing all of that information. And that is stuff that I'm basically just attaching as a property on this run object. And the real magic though is happening here, like task run context. What is that all about? So there is this task context at the top over here. And the way to think about it, this is kind of like a global, really. And what I'm basically saying is, look, if at any point in time a task definition is running and that task context is empty, then it means that that is going to be the main entry point. If it isn't empty, then it means that there's basically a parent task that is calling the current one. Oh, and then I can do something clever where that's the point in time where I'm going to say, okay, this function is a child of this other function. And that's the way this whole thing works. It's basically just this global trick where if the global is equal to none, oh, then there's no parent. Immediately put the parent task in there. And oh, the moment that I check, hey, is there a parent here? And the answer is yes, then I just add myself as a child. And that's really how this whole nested structure is made. And like whenever a task runs, I have this task run object, right? And there's lots of useful information there. But one of the things, right, this one right here, this task, this subtasks, that is just a list. So I can just add a run to another run as a subtask, and that's how this whole nested thing basically gets started. The only thing you have to be mindful of is that when the function is done, that it sort of releases its ownership of that global state, so to say. But yeah, this is how it works. And like I've always been taught that globals are kind of evil, and you have to be very mindful of them. But in this particular case, the whole reason why FlowShow works is because there's one and only one global. And yeah, this is also basically how a task definition can be done with a context manager, but also with a decorator, because there's still that one thing that I have to worry about. That's just the one global, really. So that's the way that this works. I just keep on appending stuff to the subtask. And then if I'm not mistaken, let's go back to the notebook. Yeah. So if I take this run over here, let's just zoom in a bit. So I have this run many nested. That's a function that got, so one step at a time. So that's a task definition run, right? That thing had multiple runs potentially, but in this case, there's one main one. So I can call last underscore run. And this is a task one object. And if I go for subtasks, then there you go. That's a list of task runs. And you can kind of see the nested structure happening here right now. And if let's see if there's any useful methods on this thing that I added. It's been a while. Yeah, so there's the toDictionary one. And like the nice thing is I can take that last run. I can also just call toDict on it. And this is basically the state on that one task run. And again, there's like logs that I've added, there's subtasks, and there's all sorts of artifacts that I might be able to add as well. But this is the big, there's a Python object, and I keep on expanding it. And eventually I have this dictionary, I can turn it into JSON, and that JSON thing I can put in the Ginger template, and that's how the cookie crumbles. That's how this whole thing is basically built. So again, like in a lot of ways, this isn't really that Marimo specific, I should say. Like I can't come up with a good reason why you wouldn't be able to use this inside of Jupyter. But I guess the main point that eventually I am thinking about more and more these days is just, okay, can we get these Marimo notebooks to also be more and more useful for batch jobs? And like one thing I've been exploring with this is really just the whole logging aspect of the notebook itself. And part of it is that it could make sense to, like the thing that Marimo already does, right? Like this tracing, we can have every single cell and maybe trace that. That's definitely like a valid thing to consider for Marimo. But something about being able to say, well, for my program, these are the interesting milestones, and this is where I want to put a flag in the sand and really just make a measurement, so to say. Something about that feels meaningful too. And the thing I'm exploring here is, can we use decorators and context managers to give you a little bit of control of that? And this is definitely something I will probably iterate on. Like, what I usually like to do is I like to have a side project in my mind for like a good week, and then I make a good iteration for it. Then I put it out into the wild, and then people give me feedback, and then I'll probably not touch this for like a good month or so. But you can already play with this and sort of inspect your own work. And especially, again, if you've got the situation where maybe there's LLM code and you're kind of wondering, like, hey, what parts of my program are maybe taking a bit longer? This is just a very quick, nice utility for a notebook, or maybe even a normal Python script that can give you like enough HTML to give you insight. That's the point of this thing. And the main thing I think that is going to be the biggest culprit on the short term is just performance, because I can imagine once you start putting lots and lots of states in these Python objects, then at some point you might want to have like a proper database or cache thing, such that you don't have to like load the whole thing in one sort of go. And especially for large programs, like these programs aren't necessarily big, but even for this big LLM thing that I've got, this one can actually slow down once I start interacting with it quite heavily. So yeah, maybe something clever, maybe something anyways, could make sense here. But still, this is yeah. So now it starts slowing down again because I've opened and closed this thing up a whole lot. And on hover, it needs to make, like, when I'm hovering over here, this has to update, and when I click, this also has to sort of be set. So there's actually, you know, it's actually kind of fine. But yeah, that's like a concern I've got, at least. That's something I'm thinking about. So I think that's also just about it. Like the stuff I really wanted to talk about for this week. So if there's any questions right now, do let me know. What I want to do, and I'm going to do that off screen now first, but one thing I'm going to do is maybe give a preview of what I'm going to talk about next week. Because, and I'm kind of proud of this. Let me check. No, that's the wrong one. Let me shut that one down. I've made yet another new thing that I do think is going to be super duper fun to play with, and the project is called MoFresh. And what I'm going to go ahead and do now is, it's open here. Very good. Remo edit demo.py. Yeah. Oh, wait, no, this, sorry, wrong file, CD, escape, go to YouTube material, and then Marimo edit, and then in the examples folder, I had a PyTorch demo. Torch demo, that's the one, yep. I'm going to show you something fancy, and then I'm going to make it clear that that's the topic of next week, because this FlowShow thing was kind of the thing I worked on maybe last week, and this week I worked on something else. So there's a bit of a PyTorch thing that's running here, and I'm downloading a data set and you name it. But we're going to see something fancy happen in just a bit. Let's just make this one a bit smaller over here. Okay, I have to load a sentence transformer. Yeah, sure. But kind of the fancy thing that's about to happen. Yeah, okay, so I think we're good. There we are. I'm running a PyTorch training loop, and you can see that because this thing is running in the background, well, actually it's running live, but while it's running, we have charts that can update automatically live as well. And the thing that's interesting here is, in one part, like, oh my god, like, how does this even work? Because there's a bit of a Marimo trick that I've been able to pull off here to actually get these things to run live. But you're going to see something in a moment, hopefully, in this chart that is also an interesting machine learning lesson here. Like, I'm doing a machine learning thing, and so, yeah, there we are. Boom. Beautiful. So there's a interesting PyTorch thing happening here in this demo as well. So this is what I want to talk about next week. So this week was all about, like, hey, we've got this one batch job, and when it's done, we have a view. Another thing I'm also curious about is, hey, I have a running program, and I want to see how that updates live. And there's a couple of use cases for this. One of which I do think is PyTorch, because for PyTorch, if you want to see something interesting that happens, sometimes you just really want to see that live and not see that in hindsight. Especially if there's an opportunity such that I can say something like, oh, I see something interesting, let's stop this program right now, make a change, and then let's pick it up from there. And this is a different way to work with a notebook, but it is also a thing that I think could be potentially super duper useful. Like I've enjoyed PyTorch a whole lot more now that I have access to these sorts of charts. So if this sounds interesting, definitely tune in next week. And I suppose finally another thing that I also just want to mention, we have this multi-column support now. Which is definitely super cool and nice. Like one thing that you can also do is you can organize your code in a different way. So I have a database setup bit over here. Like this is going to set up my data set. I can also just make that smaller if I want to. There's my PyTorch stuff, and then there are my views over here. You can just also add a little bit of structure to your Marima notebook. Like the cells will all figure out how to run, right? Like there's the graph view over here, like. It's always fun to make this a bit big, but like the cells know how they should interact with each other, right? So that's not something you got to concern yourself with. But the way that you interact with your notebook, that is something that you can control just a little bit more now that you've got these columns at your disposal, especially because you can like really easily hide them as well. So definitely feel free to make use of that if you've not used this feature before. Yes, and then I suppose finally FlowShow, you can find it on GitHub. If you go to my personal GitHub account, Koning/FlowShow, you're going to find it. You should also be able to pip install it. If there's any issues, do let me know. If you search on YouTube, you are going to find an old video that I made for this project. Definitely consider that video to be old. Stuff I showed you here today, that's definitely the new stuff that is also a little bit more the future of the project, I think. One question is coming in. Can you expand a bit on how you get the caller information with get out of frame? I have a similar feature, but I'm in all my stack trays of recursive nightmares. So, okay. There's a question that is coming in about FlowShow. And this is MoFresh. That's not the thing. So let's do code and FlowShow. There we are. Apparently the caller information with get outer frame. So get outer frame. So this is a synchronous call. Oh, I wrote this weeks ago, so now I have to think. Right. So the way that this get outer frame, is it the only place where I'm using it? I'm assuming. No, I'm also using it. So I'm using it in the asynchronous bit. Yeah, I think this is the. Don't I use this in the asynchronous bit as well? No, I was going to say, like, I also use this in the asynchronous bit. That would be kind of weird if I didn't. So, and the question is, like, how do you get the caller information with get out of frame? I have a similar feature with. I mean, so what I'm doing here is I'm saying, well, there's a current frame. And that's the input here. Like that's the way that I've used it. I'm mentioning this explicitly because I don't know if you're making an assumption here, Othman, or if you're looking at the same source code. So definitely feel free to keep on asking the question. But I've not really seen too many issues on this front. Like the only thing that I found that was a little bit annoying is I did have to make a conscious split between the sync function call and the asynchronous function call. And it's really just because Python has a hard time accepting anything that could be both. And it's not just the typing system, it's also just, oh, am I receiving a coroutine now or something that actually ran? It's like, you want that await in there. So like that is like the two functions are like almost identical in terms of what they do, but you need these await statements. So that's why there are two get out of frames also. But yeah, so definitely feel free to just double check the implementation. But I've not had any issues with it, and this was kind of like a first guess approach. Like this should sort of work, right? And it turned out it did. So that's also why I had no reason to doubt that this would be a way to at least address it. But if you have doubts about the implementation, feel free to open up a ticket on GitHub. But again, like the main thing that this works is this get out of frame stuff over here. It's really just to get this little bit of extra information, and I don't even know if this is like that useful, especially if you're running this from a notebook. It's pretty easy to figure out what code ran, and like knowing the line number. Like the thing that would be harder and I think more interesting is that can I figure out what cell this ran in, like that in Marimo cell, because that would be way more involved. But this would be like stuff that will be useful if you have like a Python library with multiple files and all that. Like then this is interesting stuff. But yeah, so that's only what I'm using this function for. Again, the main discovery and the thing that I really didn't know about was just like this context variable trick. This is like I was definitely talking to an LLM to learn about this, but this was using this as a global was the design pattern that ended up making everything work, which I didn't expect, but that's something I learned. Okay, one more time to see if there's questions. Otherwise, this would be a good time to also just call it quits. If you haven't already, sign up for the YouTube channel and join our Discord and all of that. And let us know what you think about Marimo, because we are definitely adding more and more features too. Final thing, like if you haven't already, like this YouTube channel, what we've started doing now is we've just started making these YouTube shorts. And the whole point of that is that that's going to be like a way for us to do feature announcements. We make so many releases like every week, like 3 to 4 isn't the abnormal week in terms of releases, but there are sometimes like new features that really do deserve a little bit of extra attention. Discord is a place where we will make a little bit of noise about that, just like our socials. But you can also expect, like if you're on YouTube, these YouTube shorts seem to be a pretty nice way for us to also get the word out there. So keep an eye on that if that's something that you're interested in. But okay, I think we're good. So I'm gonna try to find the button on YouTube to end the stream. Thanks everyone for tuning in, and see you again next week. Thanks for tuning in.